All right, so we are going to get started with surface area and volume, which is the second half of the unit that we're leading into today. So, prisms and cylinders have two congruent parallel bases. So remember, if it's a prism, the top base and the bottom base are identical, and that's how we name them. So for example, this is a prism, but what kind of prism is it? Triangular prism. Even though these sides, these faces are squares or possibly rectangles, these are triangles, the bases are triangles, so we call it a triangular prism. All right, now surface area is the total area of all faces and curved surfaces of a three-dimensional figure. So essentially surface area is if you take all the faces and find the area of each of those, if you put them together, that gives you the total surface area. Lateral area is the area of just the faces, but not including the bases. So the way I think about it is lateral area is if you were painting a room, it's the walls that you would paint. You don't usually paint the floor, and the ceiling's not usually the same color. So go with me on this one. Lateral area is like if you were to paint a room, it's the walls you would paint. So not including the bases. Okay, so not the roof and the floor. All right. So the difference between surface area and lateral area is that the lateral area would be what? Larger or smaller? Larger. Lateral area would be smaller. Why?
Because the sides are more.
The sides, including the bases, would be more than just the sides. Okay, so to find the surface area, you've got to figure out the area of each face and then add them all together. So sometimes the easiest way to do that is to think about things in a net. And remember that this is a net. What is a net? It's just it's like a flat, unfolded version of this shape. This is a hexagonal prism because the two bases are what? Hexagons. So if those bases are hexagons, we would need the area of these hexagons, 1 and 2. They have the same area, so you just have to find what? Find one of them. And then you also need the area of 3, 4, 5, 6, 7, and 8. Charlie's?
So, on the end of the quarter test.
The final?
Yes. Will we have questions like these?
All of it. Everything.
And they're going to be.
You'll have a formula sheet, so I think this section tends to be not as difficult. It's yes, but then there's also proofs and short answer. So I think this section tends to not be as difficult because if you can plug things into the formula, you should be fine. That said, if you're not good at plugging things into a formula, it will be a challenge.
There will be any of those that you poke a hole and then you paper and then you gotta open it.
No, I will never make you poke a hole. All right. Yeah. But you'll take that the Thursday before school's done. Depends on if you're honors or regular. Okay. All right. So we're going to get back to lateral and surface area. Again, lateral area would just be which ones?
The walls.
Just the walls. So which numbers? 3 through 8. And then the total surface area would be 1 through 8. So surface area is everything. Lateral area is just the walls. So just those faces, not the bases. So which one do you want to do first, the rectangle or the
harder one?
The harder one. Let's do the hexagon first. Okay, and it's not necessarily always going to be that difficult. A hexagon will be a little bit harder because remember, when you're doing the area of a regular polygon, you have to do 1/2 apothem times perimeter. So what are all of the sides? 6. So that means the perimeter would be 36. All right, and now we need to find the apothem. So remember that if this whole side is 6, what's this little piece? 3. Okay, and I'm looking for this. And in a hexagon, does anybody remember what the angle is in a hexagon? 60. So if this is 60, how could I figure out what this one is? Tan. So I could do tan 60. Tan 60 equals x over 3. So I'm really just going to do tan 60 times 3. Okay, so 3 times tan 60. Can somebody with a calculator do that for me? Root 2? Okay.
Root 3.
3 root 3?
Yeah.
All right, so 3 root 3 times 36. All right, so half of 36 is 18. 18 times 3 is
9.
18 times 3 is what? 54. So 54 root 3 is the area of the hexagon. Okay, so the area of the hexagon, the area of 1 and 2 is 54 root 3. 54 root 3. The rectangle should be a lot easier. It's 10 tall, but how wide? 6. So each one is how much? 60. So altogether 60 times 6, which is 360. So the lateral area is 360 meters squared. The surface area would be 360 plus 108 root 3. Where did I get that?
54.
54 times 2 is 108. So 54 plus 54 is 108 root 3. All right? We don't have to combine those, but you can if you want to on a calculator and make it a decimal. I don't really care. I think it's just as easy to see this way. Okay, so it doesn't matter to me, whatever way is easier for you. They will not always be this difficult because they're not always going to be hexagons. If this were just a triangle, you would just use 1/2 base times height. Okay, if it were a rectangle, base times height. If it were a circle, if it were a cylinder, you would use pi r squared. All right, the biggest thing to remember is what's the difference between lateral and surface area? Lateral should be smaller, it's just the walls. Surface area includes the walls and the floor and the ceiling. Yep. Okay. So to do it with a cylinder, the net of a cylinder actually becomes what? 2 circles and a rectangle. Why is it a rectangle? Yeah, if you unroll, like if you took a toilet paper tube and cut it and unrolled it, what would it look like? Yeah, a rectangle, maybe a square, but a rectangle, something like a rectangle. Okay, so how would you find the surface area of this cylinder?
Can you do something with the radius and the diameter?
Yeah, you have to use the radius. You don't have to use, well, you do have to use the diameter, I guess that's true. But the radius, so let's say the radius, give me a number between 1 and 10.
4.
4. All right, 4. So let's say r is 4, and then height, let's say it's 10. Okay, so for the circle, if r is 4, what's the area of the circle? Pi r squared, and if r is 4, then...
8 pi.
Okay, 16 pi. Thank you, 16 pi. I'm going to leave it in terms of pi. I think it's just easier. So if this one's 16 pi, what's the other one?
16 pi.
16 pi. So altogether, how much area is that?
32 pi.
All right, so surface area is going to include 32 pi
Wait, is it equal to multiply 16 pi?
times 2, because there's 2 of them. We have one base here and one base here.
Oh, okay.
Okay, now, what's the height of the rectangle is 10. How can you figure out how long it is?
This is
You're close. You just went like this though. You the whole circle, right? So it's the circumference. It's all the way around. So Angel, you were right. It was just you said the wrong word. So it's circumference. How do you find the circumference of a circle?
2 pi r.
2 pi r. So if r is 4, then what's 2 pi r?
8 pi.
8 pi. And what's 8 pi times 10?
80.
80 pi. So 32 pi plus 80 pi gives me
102 pi.
112.
112.
112 pi. Good. All right, so that would be our surface area. What's our lateral area?
80 pi.
Just 80 pi. Why?
10 times 8 pi.
Just the rectangle. Yep, just the walls, not the bases.
Wait, so the circumference is the length of the curve?
Yes, because if you took the whole can, like think of a cylinder as like a soda can. If you took the whole can and rolled it out, the length of it would be how much it used to be as a circle, how much around the circle. Does that make sense? Yeah. Use a what? Oh, if only we had a Pringles can in this room. There is. I hadn't noticed. All right. Okay, so surface area is going to be bigger. Lateral area is going to be smaller. So when I give you guys the formulas for these, the formula for the lateral area of a cylinder is 2 pi r h, because 2 pi r is the circumference and h is the height. Okay, once you have the lateral area, you just add the bases. So the formula for surface area of a cylinder is 2 pi r h, which is the lateral area, plus 2 times the area of the bases. And the base is just a circle, so pi r squared. So again, lateral area would be 2 pi r h. Surface area would be 2 pi r h plus 2 pi r squared. So again, if you don't remember how to do it, you can plug it into this formula as long as you know what is the r, the radius, and what is the h, height. Now, if you are a person who struggles with plugging things into formulas and keeping track of them, it might be easier to just write it out and try to figure out the areas. Okay? You will not have to memorize these formulas. I will always give them to you. Okay. So what if a cylinder with a circumference of 10 pi and a height equal to 3 times the radius? So what do we know there? And I want to find the lateral area and the surface area. So what do I know?
It's flat.
The radius is 5.
I need a radius. And how do you know the radius is 5, Ivan?
Because the radius is
No, circumference.
the circumference is
10.
10.
10 pi.
10 pi.
Yeah.
Divided. Never mind.
No, you're right. Circumference is 2 pi r, right? So if we take out the pi, 2r is equal to 10. So then r must be 5. Okay, so the radius is 5. And the height is what then? 3 times that, so 15. Okay, so first let's do lateral area. And the formula for that was 2 pi r h. So that would be 2 pi times 15. Okay, so what's 2 times 5? 10. 10 times 15. So 150 pi. So that's the lateral area. And then the surface area is just lateral area plus 2 pi r squared. What's r squared? 25. 25 times 2 is 50. So 50 pi. So ultimately that gives you what?
Where did you get 25?
What's the radius? What's 5 squared?
Oh, okay. I see it. It's
Okay.
because of these
Yep, so we're just plugging in here. All right, so surface area will always be lateral area plus 2 times the bases. So it makes sense then to find which one first. Well, the radius first, yeah. You need the radius, but then it makes sense to find lateral area before you find surface area.
Wait. I'm still getting this.
Okay. All right. If you're ready, go ahead and do the 2 practice ones on your board. All right, so if we want to find the surface area of a composite 3-dimensional figure, so take a look at this figure that's on the board. What is going on in that figure?
It has a cylinder.
It's a cylinder taken out of a rectangular prism. So it's a cylinder taken out of a rectangular prism. Basically, it's like a box with a circular hole in it. So how would we find the surface area then of this figure?
Oh, which one?
The which one?
Of the composite?
Of both? So like, okay, shouldn't you like separate them? And then
Okay.
Find its own and then add them at the end?
Well, maybe. But really, like, yes, we're going to have to do that. Except, so the surface area, again, is like what you would paint. So in this surface area, what would you have to paint?
The bases.
All the bases except for what part of it?
Middle.
The surface.
Yeah, do you need to paint the inside?
No.
No? So you really are doing the entire rectangular prism except for just the circles. So you're really just taking out the circles because you don't need to worry about painting the inside of it. So we're just going to do the entire surface area, except we're going to take out the circles. So let's start by finding the circles. What's the area of the top circle? 16 pi. So the area of both of them then would be, okay, so ultimately at the end, we're going to have to do what with 32 pi? Subtract it. Okay, so just keep that in mind, hold that thought. Now, how do we find the surface area of this rectangular prism?
The rectangular prism, don't always do length.
Yeah, so you're finding the surface area of all the rectangles, right? So essentially, because it's a rectangle, I think about it like there's the front of the box, the back of the box, those are the same. The two sides are the same, and the top and bottom are the same. So let's do the front first. If this is 24, what's the height? 20. So what's the area of the front? 480. So then what's the area of the back? Good. Okay. What's the area of the left side? No.
16 times 20.
16 times 20. So what's 16 times 20? 320. So then what's the area of the right side? Okay, and then last but not least, the top of the box is 16 by 24. We might need a calculator on this one.
384.
16 times 24 is what? 384. And if the top is 384, what's the bottom? Okay, so now what do I do with all those? Okay, I want to add them all together. 4 plus 4 is 8. 8 plus 8 is 16 plus 4 is
20.
plus 16 is
36.
okay, 4 plus 4 is 3 plus 3 is 6. What's 8 plus 6? 14. 14 plus 6 is 20 plus 3 is okay. So 2368
Divided minus 32 pi.
good minus 32 pi. Okay. Why did I not care about the surface area of the actual cylinder and I just cared about the bases? Yeah, you're not going to see it, so you don't have to paint it, okay? So again, surface area, all we had to paint was the box, and we just had to take away the two circles because we didn't have to paint those.
It was like a present.
Yes.
Wrap it.
Yeah, totally, because then you just have to unwrap two things.
It's just like there's a tree.
What?
Just there's a tree.
Ish, yeah. Yeah, but just think about like what you would need to paint. Okay. All right. Last thing, the length, width, and height of the right rectangular prism are doubled. Describe the effect on surface area. So, what would I have to do first before I could double anything?
Find the length.
Well, I have the length, width, and height, so I need to find the
Double it.
surface area. Now, would this be easier if we came up with a formula for surface area? Okay, so the front of the box, if this is the length, this is the width, and this is the height, how do you find the front of the box? Length times height. So if I need the front and the back, what would I do with it? Not squared, but times 2. Okay, so 2. What about the side?
What is times 9?
So that would be 2 times width times height. And then the top and bottom is length times width. So 2 length times width. So then that can be my formula. If you guys want a formula for a rectangular prism, here it is. 2 L times H plus 2 W times H plus 2 L times W. All right, so again, now I can just plug that in. Okay, what would happen to the dimensions if I doubled all of them?
Then we would double.
It would double. What would they be? Sorry, let me rephrase. What would my new dimensions be? If I doubled all my dimensions, what would they be?
Twice their.
Okay, so specifically 12, 4, and 6. Okay, so I'm going to use the same formula, but I'm going to do 12, 4, and 6. So my length is 12, my width is 4, and my height is 6. All right, so again, I'm just going to plug it into my formula. So 2, 12 times 6 plus 2, 4 times 6 plus 2, 12 times 4. All right, what's 12 times 6?
72.
All right, and what's 2 times 72?
14.
144? I think 144. All right, what's 4 times 6?
24.
Times 2?
48.
All right, 12 times 4?
36.
No.
48.
48 times 2?
96.
96. All right, and all together, 144, 48, and 96. $288. Okay, so what happened to our original surface area, and then what happened when we doubled it? It more than doubled. It
No, I'm sorry.
did it quadruple? Okay, it quadrupled. So your answer to this would be the surface area quadrupled. Which means what? Times 4. Which means times 4. Can you put that away? Can you put it away? Okay. All right. So find the lateral and the surface area of 9 and 10. And then for number 11, just find the surface area of this figure. So just the surface area for number 11. Okay? Lateral and surface for 9 and 10. And just the surface for number 11. Remember, we have the formula for the cylinder.